All right, so now that we've talked about an intuition for why the chain rule works and we have a general sense of what it is, let's just start practicing some problems so we can see kind of in action how this rule works. So the basic idea behind the chain rule, again, is the fact that if we're finding the derivative of some function with respect to some other function, so f composed of g of x, and we're finding the derivative of this, we can think about finding the derivative of the outer function, so f prime of g of x, times the derivative of our inner function, the derivative of our inner function, in which case we'd say this as g prime of x. So what does that look like with actual problems, with actual functions here? If we say that f of x is equal to 5x plus 1, and I think we did something pretty similar to this, we'd say that f prime of x would be the following. The derivative of the outside. So I'm going to treat this kind of here like it's its own function. So temporarily, I'm going to apply the power rule. So 2 times the coefficient, which is already there, which is just 2, times 5x plus 1. We're leaving that alone for the time being. We're going to now decrease that power by 1. So this is just 5x plus 1 to the 1 power. Now we're going to find the derivative of u prime, or in other words, the derivative of our inner function, which we say is just 5. I'm going to get rid of that 1 now. So this would just be 50x plus 10, right? So let's try some other examples. So go ahead and try number 11 right now. So if we say this is f of x, applying the chain rule, we'd say that f prime of x would be equal to 3 times the function as it is. So we're just taking this power, moving it to the front. We're going to decrease that power by 1, so that's 2. Now, what is the derivative of our inside now? The derivative of that inner function is just 2x. And we can clean that up. We can say this is 6x times x squared plus 5 to the second power. And it's a good idea to simplify when you can, simply because we're going to start using these derivatives quite a bit for other applications like related rates or implicit differentiation or even something like the second derivative test. And so it's a good idea to have our simplified function there. Let's try that with a trig function now. Something like y equals cosine squared x. Well, we can rewrite this as cosine of x squared. So this function can be thought of that. So then y prime would just very simply be 2 times cosine of x times the derivative of the inside. What's the derivative of cosine x? Well, that would just be negative sine x. So again, we can clean this up as negative 2 cosine x sine x. All right. Let's go ahead and try something like this problem here below. Okay. Well, this one here, we would also write this as x squared plus 1 to the 1/3 power. So then y prime would be 1/3 times x squared plus 1 to the negative 2/3 power times the derivative of our inner function, sorry about that, times 2x. And if we wanted to clean this up, we could write this as 2x over 3 times x squared plus 1 to the 2/3 power. Okay? Let's try something that's already written as a rational, so something like this. Again, if it helps at all, if you don't want to use the quotient rule, expand that and use the quotient rule, which we could, but we're just practicing the chain rule right now. I can rewrite this as such. So in which case we'd say y prime is equal to negative 2 times 5, 2x minus 5. Now we're going to decrease that power by 1, so that's negative 3 times the derivative of the inside, which is just 2. So y prime is just equal to negative 20 over 2x minus 5 to the 3rd power down here in the denominator. Okay. All right, let's try something like this problem right over here. Okay. So this one we're actually going to simplify because I think it's good practice for our algebra. So if we want, we can rewrite this as x squared times 1 minus x squared to the 1/2 power. Now notice that we are multiplying these two factors. So we're going to need to make sure that we apply the product rule as well. So first off, let's go with y prime, which is the derivative of the first function, which in this case, or actually, it doesn't really matter since we're just applying the product rule, which order we do this, but we can say the derivative of the first function, 2x, times 1 minus x squared to the 1/2. Leave this as it is. So this is our f prime. If this is f and this is g, this is our f prime, this is our g. We're then going to add to it plus the derivative of, or just f, so x squared, this is our f, times g prime, which is, now this is where the chain rule comes in. I'm just going to write this here. 1/2 times 1 minus x squared to the negative 1/2 power. All of that, let me just make some space, times the derivative of our inner function there, negative 2x. All of this here is our g prime. Okay, and this is where we use the chain rule. So now that we have all that, let's practice cleaning this up a little. Notice, I have a common factor of 1 minus x squared in both of these. So I can factor that out. This is what I mean when I say simplify by factoring the least power. So I'm going to write this as 1 minus x squared to the negative 1/2 power. That's what I'm factoring out. Now what's left over here? We've got, in the following here, we can say 2x. If I factor out 1 minus x squared to the negative 1/2 power, remember, when you're factoring out, what are we doing with the exponents? We are subtracting there. So this would be 1 minus x squared, 1/2 minus negative 1/2, which is just 1. So I'm going to leave that power as it is. What's left over here? Well, I've got 1/2 times the negative 2x, which is just negative x, times x squared. So that's just negative x cubed. So if I want to be really fancy now, I can simplify this as the following. Negative 3x cubed plus 2x, all of that over root 1 minus x squared. So there's our derivative. So you can see how this may be much more efficient to work with later on if we're trying to do some applications with our derivatives. Okay, and let me close it up by doing number 18 right over here. So go ahead and pause this video and give this a shot. The derivative now of this function, and so we're dealing with just the functions in their function notation, would be the following. P prime composed of q of x times q prime of x. There's our chain rule. So if we're finding this now, if we're finding the derivative of this when x is equal to 2, we would then substitute the following. So p prime, what is q of 2? Well, let me just write q of 2 first so everyone can see what I'm writing here. Oh, my mistake, and I wrote g there. That's not g, that's q. Okay, so now this is q prime of 2. So this is p prime of 3, because we're told that q of 2 is equal to 3. What is q prime of 2? Well, that's equal to 2. And what is p prime of 3 now? We're told p prime of 3 is equal to 4. We can just say all of this is equal to 8. Okay? Okay, so you can try the remaining problems on this page on your own. Hopefully they're not too bad if you're understanding what's happening with some of these other problems.